Hi, here's a common problem that you're likely to encounter. If I push the button here, you'll see that the flush doesn't run. I think just about everybody with an older Thetford toilet is likely to encounter such problems. So we'll have a look at it. Ours is a 2010 Caravan. This is the sticker that identifies our cassette type, and it is a C250. I think I said might have said 500 earlier on, and it was a 5 rather than a 6. So it's the 260 is the newer one.
So let's quickly look at the circuit board that we've got coming in. So there's the positive and negative supplies. They start off by going into the fuse, and then the negative goes straight up to the circuit board, and then from there we've got a second set of cables coming out of the circuit board which head to the reed switch, which just turns on that LED when the toilet is full, and then we've got some large blue and brown wires which feed our pump. So pretty simple circuit for a fabulously expensive piece of circuit board at about £26 to £27. So let's now look at common reasons for failure, and they occur all sorts of places. So down in the bottom left hand corner we've got the corrosion on the fuse. The fuse regularly needs to be changed with a nice fresh one because it just corrodes away like mad. And also the wires leading to that little fuse holder can also corrode away, which is in fact what happened in this situation. On the right hand side, the circuit board, that gets full of condensation. It occurs all the time. Those circuit boards are really expensive and they literally corrode on the underside. Pretty appalling. Worth actually removing the toilet on a regular basis and allowing the whole compartment down there to just get some air. So, you know, if you're storing the van, why not take the cassette out and allow the whole area to just dry out with lots of space, maybe even leave the little door open. The top left hand side there, the reed switch generally doesn't break. It's a pretty reliable circuit. However, the magnet inside the cassette can fall off, and that's another reason why that can fail to work. And then finally we've got the pump. Well, on the C250 toilets that's separate, but on the 260s then it's a submersible and the little rotor corrodes all the time. In fact, on the 250 there isn't access to a rotor, so it would mean a replacement pump if that one stopped. But those are the typical reasons why these circuit boards fail. And I have had both the fuse, the whole of the wiring and the fuse go, and the whole of the circuit board has failed as well, all due to corrosion. Okay, so let's just have a little look at what we've got going on here. Here is the mechanism, and you see it's not running. So you need to get underneath here and then release one of the little plastic clips, but you won't know what that is until you take the top off, and you can do this without removing the plastic top. Ours has come off loads of times, which is just peel back. If you do it very carefully, you won't lose much of the foil, but the perfectionists and housekeepers among you will probably want to replace this, and as with all Thetford things, be expecting to pay an absolute fortune for it. So we're going to take that off and just very carefully put it to one side, and now we're left with the mounting plate for the PCB that we've got underneath. Very easy to get out, but you'll need a screwdriver. Okay, so I'm just going to use a screwdriver to remove this, and there's a little tab here at the front, and you can ping it back and the front should lift up like that. Be very careful with it, then you can just flick it up underneath and pull it forward, and you will find the wires connecting underneath. So we've got a little block of wires here, and then we've got a couple of ones leading down to the pump. And if I turn this upside down, you will see that it's just a printed circuit board with a couple of sockets on it. So be very careful, make sure you don't lose this. Okay, so the next thing we've got to do is to separate it and find out what we've got going on. So to do that, we're going to have to get this PCB out from its mounting, and that's pretty easy. You might be able to just pull back these tabs on either side. Just before you do anything, just record what it actually looks like. You've got the curved front, and the circuitry comes out just inside the curved front there. But we're going to pull this back, these tabs, and the PCB will start to lift. Just lift that edge
very gently, and then do the same over here. Pull back the tab very gently with your fingers and lift the front edge, and it should carefully lift out. There's the front. We're going to put that to one side, and now we're left with the PCB, and I'm going to disconnect it from this connector here. Notice the wires come out the bottom underneath. That's the only way it really goes together. But I'm going to pull that apart very carefully, leave that there, and we'll have a close look at this PCB. Okay, so what you will see on this is you've got 6 connectors down here. The last 2 are the ones that go to the power, to the pump, and then we've got this little micro switch here which should click nicely, and then a load of circuitry. In all truth, what you're likely to find when you pull this apart is just a mass of white corrosion. And some people say, well, you can clean it up with a toothbrush and other things. In all truth, you cannot. There's going to be salty circuits set across in everything, and it just doesn't work. I've had a couple that I've now replaced, and it's just a bad design. You can see that the toilet itself is completely open down inside, and so condensation's constantly on it. You can make sure you completely dry it, but the secret, I think, is when you come back from a holiday, if you're going out for a long period of time and the toilet's not going to be used, just pull the toilet cassette out, hide it under the van or whatever, and leave the door flap down so that a bit of air can get around and clean it out inside. What else might go wrong? Well, the other thing is that the pump may have stopped working itself, and that's not difficult to check as long as you've got just a little bit of kit to it. You can't really do a circuit test on it, but you might be able to just run 12 volts through it. Now, as you can see, the last 2 cables here, we've got a blue on the end and a brown inside, and they run straight down into the pump. So it is actually possible to connect up to this and just run 12 volts straight into it and see what it does. So let's have a go at that. Let's just have a look at this. So I'm just going to connect 2 wires up to it. They've got some 12 volt here. I'm going to connect the brown to the brown, hold that in place, and then just briefly touch it, and we'll hear the pump run. So here we go. Let's just test that. Brown against brown, blue against blue. And there's the pump running, so we know that there's no problem with the pump, that it's not an issue of the pump stuck or frozen. It's just literally power is not making it into the pump, which is great because it means I don't have to pull it out and disconnect it, because it's a bit of a so-and-so to get back in. Okay, well, before we go any further, it's a bit noisy out here, I apologise. One of the common reasons for water to get in there is that when it rains, water runs down here, and if it's wind is blowing, it's going to blow it straight into the front. Now, there is a seal behind, but that's supposed to stop the water from going inside the van, but it's meant to drain all the way down, and there's a couple little drain holes here at the bottom, and they block up with all the muck and stuff that rolls off the roof, which eventually builds up. So just get a bit of wire and just clean inside there. Give a really good poke around, getting any rubbish out. Do the same here. It's not much really, and that just connects straight through to that compartment. So any water that's running down, I can see it here. It's run down and then it goes inside and flows its way around. Now, this seal is meant to stop it going into the compartment, but that seal is not perfect, and if I poke a wire in here, you can see that it just comes up inside. So we just need to clear this little section down here just inside the door, just to make sure. I'm going to run my finger along there and pull out any muck that there is, and it's full of gunk. Do that out, and then I find that if you blow it from the outside, it works well. There's the seal. This seal's getting a bit tired on the door, and here is our compartment, and that bit of seal there is meant to stop the water getting in, but if it does build up, it can run backwards and get in there. And we've had that during times of pouring rain. You get water on the floor in the toilet compartment because this will gradually fill up. Okay, well, let's get the toilet out and have a little look. So that's come out. move around, and immediately I can see the problem. Let me get you in there to have a look. And here is the problem. I can see if I can get this out, the fuse holder at the back. There we go. Let's have a little look. And the reason I can pull it out is because I don't know whether you can see down there, but there's two wires and it's actually snapped off inside. And the reason it's done that is not because this was free, because I took it out earlier on. I confess this is a bit of a setup from that point of view, but let's have a look at this fuse holder. And we can clearly see, here's the fuse, and if I pull that out, these fuses corrode up, so you'll need to clean those. So I always take those, a bit of emery to those, and clean them up. But in all truth, although that one is usually a complete mess, if we have a look at the holder here, I don't know whether you can see in there, but it's just completely corroded away and the wires have just snapped off underneath. Terrible system. It was bound to happen eventually anyway. So I've got in there in advance and I've taken those two wires and just stripped the ends off. And if you touch them together, when the system is all set, then the pump works fine. So all we need to do is to replace the fuse in that section. So that's what I'm going to do now. I apologise for the traffic noise, but one of the things you have to do, and you should do before you tow the caravan or do anything, because that's going to slop water around, is to drain the toilet flush down. And we do that by this black thing that's stuck up here, and it's got a little plug in the end, and you just literally pull that out and make sure it goes into a bucket. I think my one is pretty much empty now because I've had it apart quite a lot. Just gently pull that out. There'll always be some water that drops down subsequently. There it goes, and now that can drain out. And then before you do anything else, don't forget to push it back in and then tuck it back up underneath in its own special housing. Good thing to do every time. So there we go, the two wires that were connecting to the fuse holder at the back of the toilet compartment, and they completely severed off. They just corroded through, so I've stripped them back so that I could do some tests. Let's have a look at those fuse holders. You can see how corroded that is there. If I go too far, it will go out of focus, but you can see how corroded it is. And then if I turn it round to the back, we can see that they just literally corroded off. So pretty useless this thing is now. It's meant to hold clearly dozens of fuses and dozens of fuse holders, and I assumed that the second fuse space at the top was to keep a spare, but it just bounces out as you drive around. Buy a box of spares, they cost nothing. Here is my fuse that I took out, and you can see I've rubbed that down so many times, but it still works. It still tests complete using a multimeter, so it's not that. And if we just have a look on the side there, it's a 5 amp. Now I'm told that it should be a 3 amp, but 5 amp is what we've got, so 5 amp is what it had, and I will replace it with a 3 amp when I get round that far. So the problem is the broken fuse connector at the back, and so to replace that I have bought, I'm going to zoom right out, and so to replace that I have bought a separate waterproof fuse holder, and I fitted it with a 3 amp fuse, and I'm going to fit this in place. It comes with this loop of red, and what I'm going to have to do is to cut the loop and then solder it into place. I could just use connectors, but in all truth I am happier with soldered connectors. Let's go. Okay, well I need to join the wires together, and I could use a chock box, but the problem is the corrosion. So I suspect it would just corrode again and again and again. So what I'm going to do is I'm going to use, as well as my 2 sets of wires, I hope you can see those, I'm going to join them up using a solder, and then I'm going to encase them in a little bit of heat shrink. Now you should ideally use the smallest heat shrink that you've got. I've got some 3mm, but it won't actually go over the thick red wires on the fuse container, so this is going to be 6mm, and I'm hoping it'll shrink down enough and just provide sufficient seal to protect it for a while. Okay, so job number 1 is to tin the end of those wires with a bit of solder. That's going to be a bit of a nightmare because they're stuck down the back of this tunnel and I can't reach. I've already tinned the fuse and they're made out of a steely wire, so that didn't tin very well either, but let's have a go at this. I'll take my specs off, I think. No, just got the wrong specs. Okay, so I'm going to have to go to plan B. It's impossible to tin these wires. The ones on the fuse, I don't know what metal they're made out of, but they feel like they're probably stainless steel or something like that. And they barely take any solder. Managed to get a little bit on there. And the wires at the back there are of a material as well that do not take solder. So that's scuppered my idea of soldering it all up. Well, I do have a couple of choices as to how to deal with this. I can either try and use a chop box to connect at the back edge there, or you'll see that the 2 red wires that they go down are actually running down the side here, and I could just cut them off down here and make it easy for myself and connect in, because there's the live and the neutral coming up from the battery that are powering it, and one of them, the neutral, goes up to the top and the live goes running off down towards that and then comes back again and goes back up to the top. So the live and neutral are delivered to the top, and then we've got 3 black wires that come back down and they go to that reed switch that's sitting at the back there. So that reed switch, so at the back here we have a reed switch, and I did replace that, it probably wasn't needed. That's what detects when the toilet cistern is full, because there's a little switch inside, a magnet floats up, and then when it gets to the top it gets flicked into right next to the little reed switch, and that turns the light on in the compartment. To be honest, we know when it's going to empty, and I empty it long before it gets to that point anyway, so I'm not really that bothered. Right, well, here is my answer. You can see the 2 red wires come out here on the right, and then they go into a chop box. Now that's just temporary, just want to see whether that will work, and then I'll put a sealed one on afterwards. And here's my fuse mounting, and it's a waterproof fuse, and it contains a 3 amp at the moment, but I think it's going to need a 5 amp fuse. So I've really just connected it back in together. I've put the sliding old fuse container in. I now pull this forward and tuck it all behind like that. Now it's sitting in the pool of water that's going to build up down here, but for the moment I just want to check that it's all working, and then I'll tidy it up later. I'm still tempted to fit over here to break into the 2 red wires that are going down, these 2. I'm tempted to break into those and put a nice little fuse just here on the right hand side. Let's see how it goes anyway. Okay, so here comes the moment of truth to test whether it's working or not. Listen. So that seems to be working fine, so we can put it back together again. I did learn something, and that is that the correct fuse is a 5 amp fuse. I had a 3 amp fuse in there, I tried it and it immediately blew. 5 seems to work fine. I don't know whether you can see that, but the current blew my 3 amp fuse, so it is, the correct one is a 5 amp fuse. Okay, so here we go. I've put the circuit board back together again. Don't get it upside down, make sure you know which way round. So the button goes against the plastic, connect all that up and make sure it's the right way round before you then add this connector, then put the connector on and clip it into place, and then push this down and it's in. Then we can put our sticky Thetford sticker on the top. 13 quid, I've just looked it up, £13 for a new sticker. It's obscene, isn't it? £27 for a new circuit board, and that is now working. Okay, the tools that we have used a flathead screwdriver, we've used a pair of wire cutters and a pair of wire strippers. I've also used a multimeter to check things, and I also had a little 12-volt supply that I was able to use to check the functioning of the motor, but you might find that that's not necessary, particularly if you can work out what the resistance of the motor is. But it's now all working properly, the way it should be, and it's worth giving it a really good clean out while you've got it all apart. Okay, thanks very much, and let's return next time something else breaks. Before you do anything, or as you do everything, don't forget, either take photographs or make diagrams of how everything was connected. It's possible to put the circuit board connector the wrong way up on the circuit board, and then you will blow the fuse. And that's just really frustrating because you're not sure whether you've blown the fuse or the circuit board. I know, because that's what I did. Okay, so don't mess up. All the best. Take care. Bye.